everyone. I'm Grace Lee. So actually, this is my first time to attend the Search Solution conference. I'm coming from IR background for my PhD study, but I did my PhD in Singapore. So all of my IR network is in Singapore or Australia or mainland China or Japan. And then now I'm in the UK. I'm really happy to be here and then talk to you all. Yeah, so today I would like to talk about the retrieval-augmented generation for legal IR. So now I'm affiliated with the Thomson Reuters, and specifically I'm in Thomson Reuters Labs. And first of all, I would like to give you the brief of introduction about Thomson Reuters Labs. So Reuters, you may heard of this news media, most of you, maybe Thomson Reuters, maybe not that familiar with it, but Reuters kind of news media, you may heard of it definitely. So Reuters is one of our component in Thomson Reuters. They are releasing news, and the other part is the Thomson Reuters part that develops the legal professionals or legal application for legal professionals. So I'm working in that sectors. So we are developing wide range of legal application for legal professionals, such as like legal research product, Westlaw, and also the tax and accounting application, such as Checkpoint. And with Thomson Reuters, we call it TR, so I may say TR. So we are making a strategic partnership and also strategic acquisition as well. So lately we made a partnership with the Microsoft, and then we are developing Microsoft Copilot 365 together. And particularly our team is actually working in Microsoft team, and then we are co-developing Microsoft Copilots. And also another latest acquisition is the Casetext. So Casetext is the small startup who's developing a legal LLM or legal chatbot, and then they had an exclusive agreement with the OpenAI, so they have the exclusive access to the GPT-4 and GPT Turbo, etc. So we are in the all under the Thomson Reuters umbrella or organization now. So Thomson Reuters, we have the very competitive advantages. So we have authoritative contents, wide or humongous range of legal contents, and also we have the in-house subject matter expertise who are lawyers and attorneys, and they are actually our machines prediction and generation. They are evaluating it manually, and also they are actually evaluating our end products and then give us feedback in a very rapid fashion. Yeah, so without further ado, let's go with our main part of the presentations. Yeah, so spoiler alert, I will talk about ChatGPT again. So I think so far every presenter has talked about ChatGPT, and then I'm sorry, I'm gonna do that again. Yeah, so we've been going through a lot of really rapid advance in AI area. Yeah, I've been in this IR or machine learning area about 10 years. I cannot say like 17 years. I can see a lot of more experienced people, but I can start with the big data kind of stages. So we went through big data buzzwords, and also more lately, we went through the deep learning era, and then we talk about CNN and RNN and STM, and also more lately, BERT model came out and attention mechanism also came out. And also, yeah, we cannot miss out generative AI. So when we talk about generative AI, ChatGPT cannot be missed out. And this is very, very monumental achievement in terms of generative AI, but also in terms of educating and informing people. Even my parents and older brother, older sisters, they are talking about ChatGPT. Previously, when I was talking about my machine learning work, they were not that interested at all. But now, whenever I talk about generative AI and ChatGPT, everyone is kind of giving me the shining eyes. Yeah. So the ChatGPT made a really, really good progress or kind of great general awareness to our kind of people outside of AI industry. Yeah, and particularly interest from legal industries are unprecedentedly strong. So even for now, 2023, a lot of legal professionals' works are very manual and time consuming. And we already talked about a lot of presenters also mentioned about this attorney kind of who made up their brief using ChatGPT and then actually submitted and then it got caught. So this news actually tell me about actually two takeaway stories. So one is legal industry has the very, very strong interest and needs about like assisting their manual workflow and also semi-automating their workflow. And also another one is this story is revealing the limitation of generative AI or large language model. So now people are questioning about hallucination and then trust or credibility of the machine generated text. So now we know this level of limitations, but generative AI is here and then it's such a buzzword and the new technique, we cannot just give up on it, right? So now we are asking this question to ourselves. How do we mitigate this hallucination in the machine generated text? Or in other words, how do we ground our machine generated text? So one of the most common framework is retrieval-augmented generations. So this is one of the approaches that can mitigate the limitation of generative AI's hallucinations. And one of the very first paper is published this meta researcher, Patrick Lewis. And then this paper has been published in 2020. And then since then, numerous blog posts and tutorials has been came out. And then now you Google it and you will find a bunch of material related on RAG. Yeah, so RAG's main idea is providing relevant content to LLMs. So if you use the ChatGPT, and ChatGPT will get your question only, which can be considered as just your prompt. And then they generate they answer your question. But here the retrieval-augmented generation is on top of your question, actually you are providing additional information, which is the relevant material. And then this relevant material will be found by our retrieval system. In this way, we are giving more resources to GPT-4 or other types of LLM to utilize or incorporate in when they are actually generating. And also at the same time, as a user or as a scientist, we can have a little more control over the machine generated text. Yeah, so this is the framework I got it from my colleagues, Hamed Jamani, and then he published the retrieval-enhanced machine learning. That is a paper title with the Google colleagues. And then they proposed these types of framework. But the middle at the top is the most simplified one. So we have the prediction model on the left-hand side, and then we have the input from the bottom, and then the output is coming out from through our prediction model. And then specifically in the RAG context, this prediction model can be LLMs. And we have the information access system. You can consider it as the retrieval system. So whenever we have the user query, instead of just using an LLM only, actually we are going through this user query to retrieval system and retrieve the most relevant content. And then together with user query and relevant content, we generate the text, which is the output. And then at the bottom, there are more upscale or complicated frameworks. So in terms of this kind of user one-way interaction, we can have extra interactions such as caching mechanism or the storing mechanisms. But I will just use the most simplified framework, which is at the top. So you can consider it as the prediction model as the generation part, and also the right-hand side is the information access part. You can consider it as the retrieval part. And for the generation part and retrieval parts are two major components in the framework of the information retrieval augmented generation. And then in both areas, there are a bunch of work can be done to develop your industry level application. So particularly for the generation part, first one is actually training and fine-tuning your own LLM. But honestly, this might be a little bit of exclusive activity because not a lot of companies are having that large amount of training data and also resources. So fine-tuning can be one of the other approaches, but still, this is still a long way to go. A lot of researchers are putting a lot of effort on that. And another one is a little more easier way to tackle the generation part, which is the prompt engineering. And then prompt engineering, anyone can be the prompt engineer. You can try different prompts. And from my experience, from my experience talking to other colleagues within my company or outside of company, actually computer scientists are not a good prompt engineer. So what I heard is actually linguist who is very, very good at prompt engineering, kind of looking at the LLM's output and then find out what's the pattern between word choices, and then they give the right prompts to the large language model. So prompt engineering is one of the also interesting area. But in this talk, I would like to focus more on the retrieval sector, retrieval part. So retrieval part is kind of, you can think of it as almost every technology we know in the conventional IR area can be applied to this RAG framework. And then, but of course, we cannot just copy and paste because there is the bits are different. So I will go through the major differences in the next following slides. Yeah, so when we are going through this retrieval components, this is the very, very simplified workflow. So in the RAG workflow, a more complicated version is interaction between retrieval component and generation components. So once we send the retrieved contents into generation, and then based on this generated content, we actually send this one into retrieval model. So these two components can be interact. But more simplified version is still one-way direction. We do the retrieval, and then whatever outcome comes out of retrieval, we send it to GPT or LLMs, and then LLM will generate output. That is our final output. So this is very, very simplified workflow, but I will focus on this simplified version in this talk. Yeah, and then this retrieval component can be also divided into the multiple components, but mainly in industry, a lot of people are using more like 2 stages retrieval. So first we did the initial retrieval using like ANN search or using vector database. So we do the initial search, which is the retrieval component, and then we do the re-ranking on it. So that is the more like 2 stages under the retrieval component. Yeah, so before going into the little more technical knowledge, one thing I would like to talk about is the importance of the data. So importance of data is we've been heard of it like decades. Since big data, we know the large amount of the data, but now on top of that, what we need is actually large amount of quality data. So large language model is already trained on massive amount of the text data which are available on the web. But now what we need is exclusive and quality content that you only have access to. So that means our already trained large language model haven't seen that data. So if you have the quality content or exclusive content, you can save them into database, and then you can use the retrieval algorithms and then actually send it to LLM for your generations. In this way, you are actually providing additional or new fresh data to large language model, which it hasn't watched yet. Yeah, so in this framework, we talked about retrieval component and also generation component. And then within retrieval component, we have the initial retrieval stages, and then second one is the re-ranking stage. So in the first stage, we do a lot of initial retrieval using relatively simpler algorithms, like BM25 or vector database, ANN search or KNN search. And also if you have the pre-trained model, and then you can use your own pre-trained model in the very, very first stage of this framework. And the second one is the re-ranking part. And the re-ranking part is doing inference on the already smaller set of sample, which are already came out of our initial search. So search space is already small, so it's very manageable to have your own re-ranker model. So people often fine-tune this re-ranking model. And then for this re-ranking technology, there are a variety of some techniques starting from more classical method, like supervised method, but now people are also doing modern approaches for re-ranking as well. So people are actually using GPT-4 or even LLM for re-ranking. So once you get the initial retrieval results from the very, very first stage, and actually you send bottom 20 items to LLM and ask which one is the most relevant. and then you get the top 30, and then they slide the window, and then they get another 20, and then ask to LLMs. So they do the re-ranking using LLM as well. So last one is the generation components. So of course, generation part rather than we have a lot of access, we have a lot of LLMs model. So when now it's kind of a little bit calm down, cool down, but maybe 3 months ago, almost every Monday when I opened my laptop, there was the new LLM model, it was kind of a lot of active release. So I can just mention the couple of them. So Flantify, Vicuna, Llama, Bloom, and Anthropic's Cloud, and ChatGPT, and also GPT-4, and also now GPT-4 Turbo. Of course, depending on your budget and depending on your license situation, you can choose your LLMs. But here, general consensus is there is no gold ticket or gold answer for the LLM. It all depends on your own application. Maybe GPT-4 would be working very well your own specific application, but it might not be working that way application B and C and D. Yeah, so in this framework, this is still very nascent stages of the literature. The initial paper was published on 2020 by the Patrick Lewis. So it's been just two or 3 years. So it's everything can be considered as the moving part now. But one thing from my experience, one pressing research question I can see is aligning between retrieval and generation. So here in this framework, as I explained, direction is only one directional. And also first part is separated as the retrieval, and the next one is separated as the generation. And then there is no active interaction between this retrieval part and generation part. And when we are actually developing these retrieval components, we are relying on more conventional classical IR approaches. For example, when we are fine-tuning re-ranker model, we use the human relevance or track data set or typical IR-related IR benchmark data set, but those judgments or relevance judgments are for human judgment. And we, at the time when we are creating this benchmark track data set, we didn't expect this data set could be used for machine. We always made this data set for the human evaluation and human-based relevance coming out of the humans. But now, after re-ranking, our output of re-ranking model or retrieval part is consumed by LLMs. It's not consumed by humans. So we can ask the question, the relevant content judged by us as relevant is also relevant by machine? Is it a yes, we know, do we know? Or do they have the more relaxed definition about the relevance, or do they have the more strict or narrow definition on relevance? We don't know about that yet. But now, so far, all the researches or all the industry work is on happening in retrieval part is based on our previous work coming out of IR community and IR research group. So we don't have the relevance label designed for machine. So that part is kind of, I named it as the aligning between retrieval and generation. Yeah, this question, does the most relevant materials from retrieval system are the most relevant material for LLMs? So that's the question. And then there are a couple of latest papers trying to answer these questions. But still based on this latest question, there are still remaining questions for developing industry scale, large scale applications. What is still those papers are introducing multiple supervised models, which makes it a little bit hard to integrate it in our product level. And also, when we have another supervised model, we need the training data. So it takes a lot of time and energy for training data creation. And also it's not simple and straightforward approaches for industry level application in terms of latency as well. Yeah, so this is the challenges in large scale legal AI applications. So this is one about, and I made this slide for more tailored for the legal IR or legal IR AI application, but I think this is more generally applicable for all the different domains of industry application, not limited to legal domains. Yeah, so still legal domain itself has been long-standing domain. So it's been there decades. And then when they started the legal domain, everything was manual. When they have the legal court document, nothing has been digitized. And then everything was written in paper, and then there was a library. And then we are doing a lot of modernization, but still we cannot ignore or cut the connection from our beginning or our starting point. So there is a lot of legacy related applications. So when we are working on our legal text, still a lot of data format is in not in clean JSON format. So we had to do a lot of kind of somewhat tedious kind of data processing as well. And related to this data processing, one other very, very important one is the metadata. So when we have the vector database, we do a lot of ANN search, but still here, if we have the clear, very concise metadata, we can really improve the precision greatly in terms of ANN performance. So if we in legal NLP or legal IR, metadata is very, very important, such as jurisdictions, so what type of agreement or contracts. So contract documents, maybe termination provision or termination clause would be there in every types of contract documents, but depending on what kind of contract document. Are you talking about contract document about M&A between two companies, or the contract document or kind of landlord and lender? So depending on document type, this termination clause content should be tailored towards. And then these tailoring can be easily done by metadata. So if you have any metadata in your vector database, or when you're working on this reg pipeline, please do not ignore it. But I understand it can be a little bit tedious, and then it requires a lot of data cleaning as well. But once you've done it, it will be really, really valuable resources for your application. And second one is the latency and inference speed. So multiple ML models for single applications. So now in our simplified workflow, we have the retrieval component and generation components. So we have the retrieval part. It can be done with the simple BM25 or Elasticsearch database. And also there is the generation part. If you're using GPT-4, you can connect API. But on top of that, adding additional machine learning model can be easily become a huge pool of technical depth. So even large IT companies are a little bit reluctant to have the multiple machine learning model in their single pipeline of the single application. And in terms of company's perspective or organizers' perspective, they have the multiple products, which means multiple application. And then if each application has the multiple machine learning model, it's very high risk to take. So still in terms of the reg pipeline and retrieval-augmented generation, there is the critical issue about latency and inference speed. And third one is the trust and explainability. Yeah, absolutely. This reg pipeline can help mitigate the machine hallucination, but this is not the solve the problem 100%. And also, especially when you are developing an application for legal professionals or in the medical industry for medical doctor, their requirement is very, very high. When we are writing a machine learning paper, our performance become from 80% to 85% accuracy, we celebrate it. But for legal professional or medical professional, 85 is not good enough. They want to have above 95%, 97%. Almost they want to have the 100% of performance. Of course, they do not say that, but yeah, they require very, very high performance requirement. So still there is the pressing or challenge in terms of trust and explainability.
5 minutes, Grace.
Yes, thank you. And also last one is the model monitoring and user feedbacks. Yeah, this is also the wrapping up with the whole machine learning life cycle. So once we deploy our machine learning model, we need to see how it's going to serve or how it's being used by our customers, and then get the user feedback. And in the context of the large language legal AI application, I brought a summarization example. So summarization is one of the promising downstream tasks using generative AI. But in legal context, summarization can be meaning very, very different things depending on your level and your job titles. So for example, if you are a junior attorney, you have to always review the thousands of documents and then make the summary and then actually submit to your superior and then check whether you understood correctly. So in that sense, the summarization capability is going to be really, really helpful. But in another scenario, let's say you are an executive lawyer at a huge law firm. In that case, in your context, summarization technique is very, very different from junior attorney's summarizations. So if you are an executive attorney, your summarization skill would be very, very important. Just finding out differences between multiple documents because you already have the big picture in your head. So depending on users, your summarization or your application's capabilities should be customized or personalized or tailored to the users. So to do so, we really need the model monitoring and the user feedbacks. But this part hasn't been actually discussed in terms of generative AI or RAG pipeline. Yeah, under the constraints of license and pipeline and budget, this is more like a realistic constraint when we are working in the industry. So this is also, there is not many things we can do as a research scientist, but this is a very, very important restriction or constraint. So I would like to mention it at the bottom. Yeah. So this is a conclusion of my talk. So we briefly talk about retrieval-augmented generation and overview and simple pipeline, and also what kind of elements are in the pipeline. Yeah, and then now I'm working on this RAG pipeline and we're actually developing a product. So actually, I would like to have a little more active discussion with you if anyone is actually working on this RAG pipeline at the moment. Yeah, so we also lastly, we briefly talk about RAG for legal application. We talk about multiple major challenges there. Yeah, so I would like to conclude my talk in a little bit more positive note. So yeah, after going through deep learning buzzword, as an IR PhD student at the time, I was feeling like leaving behind because everyone was talking about NLP rather than IR. But now I feel like our time is coming back thanks to generative AI. So this is the great time for information retrieval community together with the advances in generative AI technique. Yeah, thank you so much.
I feel better from just seeing the bottom line on that slide. Right. Questions to both Charlie and to Grace, because there's some interesting relativities. Oh yeah, right. Can I start with?
So I'm in the old crowd. So I've been doing IR zillion of years ago, and there was an area of research in IR which was called pseudo relevance feedback.
Yeah,
is that the same with the RAG thing? Kind of. It will be different. It's for the generative AI, but we went through the thing. You get your results. You assume the top 10 are relevant. You assume, and you just feed it back.
I think, can I take it and please add later? Yeah, I think there is a great similarity. Like another similar technique we are talking a lot now is the few shot learning or context learning. So we give the relevant example in the prompts, and actually LLMs are using those most relevant examples actually to generate the text. And then actually this relevant content can be coming out of the retrieval results, and then it's the same as taking top end components, right? And then doing the retrieval again, or using query expansion or modifying ranking algorithms. So I see there is a lot of overlap and similarity between like little bit classical approaches and then new approaches. But I see kind of this is common pattern in the like research. Yeah, absolutely. Every technique is kind of coming back, but in a slightly different context.
Thank you.
There are two questions down here.
Yeah, one question for Charlie, because Grace showed here in the architecture diagram, the component that goes to the augmented database, let's say. It's called information access, I believe, in Grace's slide, but you had a vector database directly. So
Which was just one example of how you could, that provides the information that you can then access. I mean, you whatever system you have to cover that information access part, it could be a traditional search engine, it could be a vector database, could be the two. It's anything really, but it's somewhere that works in that traditional model of, here's a query, please give me some results.
Okay, so there's no
just different ways of expressing the same thing.
There's no advantage in using a vector one in particular.
I don't know. I mean, I think if you're just looking at the search problem these days, you'd be looking at a vector database as well as a traditional search engine and a hybrid approach. You're going to try and solve that search problem, and you're going to be considering that as one of the options. It's not, the options are the only way to do it. How you actually implement it. I think what the very interesting point from your talk was the idea that what the results that come out of that system, should they be more machine readable than human readable? Because we are basically just splitting the systems apart, and you could look at the bits in between. You could look at the results coming out, and you could read through them like a normal set of search results. But perhaps you want to include particular metadata. Perhaps you want to include relevance scoring of some kind, and give the LLM more to work with. That's really interesting. I just wanted to just very quickly come back to your point there about
pseudo relevance feedback.
Yeah, pseudo relevance feedback. Again, I think we're just at the beginning of some of this thing, because this is a one-way road. We're taking one system, getting the outputs and shoving them to the other system, and we're not letting one interact with the other in a way. But also, you've got other interesting ideas where I've seen. For example, you can ask, you can say to an LLM, here's the answer. What would be the questions? Which is really interesting, because then you've got synthetic query generation. You've got that there's all kind of feedback pathways that I think we haven't really explored yet. And we're going to need to experiment with them and test them to find out what works and what doesn't. Relevance feedback, I saw that 20 years ago.
I was there.
Back in the early days. You'd mark relevant terms. You could say, here are some terms that were in this result set. Tell me which ones were really relevant to your question. Feed that back in, use that to improve the search. And this feedback loop is very powerful. We know that. So again, I think we're just at the very beginning. So
I had a question just quickly on that point there. And we were doing some work with Microsoft Cognitive Search last week, and they had some stats on the retrieval accuracy of keyword-based search, vector-based search, which was better but not brilliant, and then the re-ranking with the semantic re-ranking on top of both of those put together, and the combinations were getting better overall relevance than either vector or keyword on its own. So again, it seems like the combinations overall, they build on top of each other.
Did they give you the experimental methods, how they actually created those stats?
They may have mentioned, I'll check my notes and get back to you on that. Actually, Grace, I had a quick question. Thank you very much, both of you, for the talks. Sorry, I was a little bit late for beginning of yours, Charlie. I'll catch up later. Thank you for that one. You mentioned there earlier, you sort of skipped over and said there could be a two-way conversation with the retrieval and the LLM. And I wondered whether what you were skipping over there was some of that, perhaps using the LLM to enrich the querying, because that's one of the things I've been looking at. You say to the LLM, what query terms might I want to use to answer this query, especially if you've embedded, say, a golden example in your prompt.
Yeah, I think that's also the very, very good approaches. Kind of one of the approaches make it like bi-directional interaction. And also another way I was thinking for the bi-interaction is actually building this whole pipeline together for the single like training objective. Now this two part is separated, and then generation model is trained as a standing alone. And then retrieval model can be trained or may not be trained, but still is separated. But if we have this shared parameter, and then if we train from whole pipeline from the beginning together, and then actually they are naturally interacting together.
Right, thank you.
Just to add to that, I think that, you know, what you're doing then is you're training the user. When you do the traditional relevance feedback, you're helping the user ask a better question. I think the other thing is the outputs of the RAG system, you then got again a question and an answer for the whole pipeline. Why not store that and use it somewhere later? Why can't that go back into your database and use it to, again, iteratively, the answer that people liked for this question last week might be useful in the future as well. You know, we've got that vector store, we've got that store, we can put other things into it, and it could be the outputs of the RAG system as well. But I do think there's a thing here. If we're using 15 different models in different parts of the system, I think and you mentioned this, there's a risk there that we're going to confuse ourselves.
Right.
Okay, Sammy's got a question. Peter, would you like to come up and get yourself comfortable? Peter, while Sammy asks this question.
There seems to be a race for increasing the context size of these LLMs. So GPT-4 went up from, I think at the start it was 8,000 tokens, and now it's 116,000 tokens. Yesterday, Anthropic published the newest Claude version with 200,000 tokens, so roughly 500 pages. I think they advertise it at, and they also, I think they had some marketing slides advertising it as a replacement for vector retrieval, for example. Do you think, what are your thoughts regarding retrieval augmented generation? Is it a good idea to move, basically sifting through the noise and selecting the relevant information into the model or into the context size of the model?
I'm suspicious again of the whole AI rule-based search argument generally. I think the context window is an interesting thing because again, it reminds me of chopping up data into paragraphs when you're indexing by paragraph and wanting to retrieve particular paragraphs. But I've seen 3,000 page PDFs. You know, it's that Blade Runner moment. I have seen a 3,000 page PDF. But you know, you'll never fit everything into a context window. But come back to what you're actually trying to do. What are the answers you're trying to produce in the end? What the use case? And bigger isn't always best.
Yeah, and for me, I don't have any clear answer for that, but this is more like my personal information or opinion or philosophy. So I feel like this larger context window is more like a marketing race. It's more like red race, but yesterday, literally within our team, we talk about now it's becoming context race rather than red race. Every company is racing for the larger context window size. But for me, that is not the critical performance component for RAG. And of course, I'm biased. I'm coming from retrieval IR background. So finding relevant content is a lot more important. So if we are able to find the most relevant contents for the GPT or LLM, actually we might not necessarily need a 200K context window.
No. Use case, you know, lawyers deal in clauses, you know, part suppliers might deal in part numbers, you know, medical professionals might deal in 3,000 page PDFs. I don't know what it is, but you know, focus on the problem, I think, and you know, use the minimal viable solution.
Okay, last
Just a very quick one, following up on what Charlie suggested. Here's the answer to the question. So if the answer was 42, just to pick a simple one, what would be the question?
I think what's the new thing that Elon Musk has produced? He's produced some kind of AI system. Yes, he's called it Grok. And then he said it was really good at answering that question, you know, for which the answer is 42. There's a sheer horror at him conflating two entirely different works of science fiction. That was my annoyance at that.
Okay.